In this video, we will cover call recording options for on-premises deployments. Here's the agenda. We will start with span or port mirroring, then move to phone audio forking, followed by CUCM call recording options, and then we will cover media proxy, and lastly, recording for analog interfaces. The first one we're showing is span switch port analyzer. Span mirrors traffic on one or more source ports or VLANs to a destination port in a network. There is no specific configuration required on CUCM for this, since CUCM is not aware of this kind of recording. The next method is the phone built-in bridge recording, where CUCM checks the DN recording profile and sends an invite to the SIP recorder. You can see the red line shows media traffic and the blue line shows SIP signaling. That is for this slide and also in the comment slides. If built-in bridge is configured, CUCM tells the phone to forward media to the recorder, and the JTAP signaling from CUCM to the recorder is used to provide metadata of that call. We have two options to record. You can configure it to automatically start recording or to selectively record by pressing a soft key. Built-in bridge is a very common method of call recording, and it is supported by most phones and also in MRA deployments. This method is what we call phone preferred. The next method is network-based recorder. And as long as the call flows through a queue, the customer can use a network-based recording method. CUCM sends the forking request over HTTP to CUCM, and CUCM then sends two media streams towards the recording server. If network-based recording is configured but not available, recording will fail over to the phone built-in bridge. A few things to keep in mind: the calls have to flow through the queue. There is no HA or preservation of call recording audio if the queue goes down, and survivability, call script, and SRTP are supported with this method. Another method to record calls with CUCM is DALPIR-based SIP rec recording. In this method, CUCM is not involved in the decision to start the recording, and all calls flowing through the DALPIR with the call recording profile will be recorded. Customer can have CUCM HA, and then calls will be preserved in case of the active CUCM becoming unavailable. A couple of limitations to keep in mind are that transcoding on the fork leg is not supported, and we can only record call legs with RTP, not SRTP. Then we have the media proxy offer, where a call can be forked to multiple recorders. In this diagram, I'm showing 3 recorder servers, but you can fork to up to 5 recorders. CUCM 12.5 onward supports the media proxy product, and customer can use CUCM in built-in bridge or to fork the media. CUCM or built-in bridge to fork the media. CUCM and media proxy cannot be co-located, and the minimum version on the media proxy is iOS XE 6.10. In this diagram, you can see the media forking comes from the phone instead of the CUCM, but essentially it is the same architecture as the previous slide. In iOS XE 17.3, we added support for SIP rec. So in this case, we see the SIP rec call recording method on CUCM. Then the media proxy can fork SIP rec and media to up to 5 recorders. Currently, SRTP is not supported for this feature, but this might change in the coming releases. Stateful HA is supported, and there is no transcoding support. The last method we're covering is call recording for analog interfaces, FXO or FXS ports. In this method, we support the newer platforms of ISR 4Ks and BG400 series. SIP rec is used for signaling to the recording server, and this feature is licensed separately using smart licensing, and SRTP is not supported. This covers the call recording methods for on-premises. If you have any questions, please reach out to Ask CUCM or Ask CUCM WebEx Team Spaces, or you can reach out to me directly. Thank you.